Alright, section 4.6, problem number 17. We are given an equation and we are asked to solve this equation. So these equations are known as rational expression equations. And the first step in solving one of these equations is to realize that we really don't want fractions. Okay, we've got these kind of messy looking fractions in our equation and we'd love to get rid of all of them. So the first step in getting rid of the fractions is to actually factor each of the denominators. Okay, so we won't be changing any of the numerators in this step. We will simply factor the denominator. So my first denominator, I can factor out a 3. Second denominator, we can factor out a 4. And in the final denominator, we can factor out a 2. We're looking for the least common denominator of these three denominators. Well, for constants, we see that 12 is the least common denominator for those constants. And what we're going to be doing is multiplying every part of this equation by the least common denominator. So 12 is going to be part of that least common denominator. We also see that there are factors of a plus 1 in a couple of our fractions. So we need to have a factor of a plus 1 in our least common denominator. And we only need one of them because there are no denominators that have more than one copy of a plus 1. But we see that this denominator also has a copy of a minus 1. So that needs to be in our least common denominator as well. So we're going to multiply every fraction in this equation by this least common denominator. So when I multiply to this fraction, I see that the 3 and the 12 will reduce to be equal to 4. 4 times 7a is 28a. And then I see that this a plus 1 would cancel with this a plus 1, but I would still have to multiply by a minus 1. All right, next term. The 4 and the 12 reduce down to 3. And 3 times 5 is 15. In this case, the a minus 1s will cancel, but I will still need to multiply by a plus 1. Last fraction, the 2 and the 12 reduce down to 6. 6 times 3a is 18a. And once again, like the first fraction, the a plus 1s will cancel when I do this multiplication, but I will still have to multiply by a minus 1. Alright, then go ahead and do all of the distributing that needs to be done here. So here I will have 28a squared minus 28a. Then distribute negative 15. I've got negative 15a minus 15. Finally distribute the 18a, so I've got 18a squared minus 18a. Alright, now I want to consolidate everything that I can and move it all to one side. So I'm going to subtract this 18a squared from both sides. That will leave me with 10a squared on the left. Here I'm going to combine these together, so negative 28a minus 15a is negative 43a. But then I also want these a's to be on the left as well. So I've got negative 43a, and I want to add 18a to both sides. So in this case, I should wind up with negative 25a. And then negative 15 is the only constant in this equation. Alright, now I've reduced my very difficult looking equation down to an equation that is much easier to work with. So the first thing I would do here then is factor out a 5. And that simplifies the size of the numbers that I'm working with. And then at this point I can choose whether I want to try to continue solving this using factoring, or whether it might be a better idea to go ahead and use the quadratic formula just in case this doesn't factor. In this particular problem, I can see how it factors pretty easily. If you prefer the quadratic formula though, that's fine as well. So this will factor into 2a and a. We'll have a 3 here and a 1 here, and this will be a negative, this will be a positive. So that if you were to multiply this back out, you would get back to this polynomial that we started with. Okay, so I've got solutions that'll come from this. Obviously 5 cannot equal to 0, but if this factor, 2a plus 1, were to equal 0, then that would tell me that a is negative 1/2. And if this factor were to be equal to 0, then that would tell me that a is equal to 3. Now, there's one remaining step on this type of a problem, and that is checking your solutions. You don't have to plug it in and do all of the checking, but you do have to make sure that these solutions won't cause one of your denominators in the original problem to be 0. Dividing by 0 is never a good thing, and we want to make sure to avoid that. Well, in this particular case, the numbers that would cause one of our denominators to be 0 here would be negative 1, here would be positive 1, here would be negative 1 again. So as long as our solutions do not include the numbers negative 1 or positive 1, then we're okay. And in this case, we are okay. So both of these solutions will work in this problem.